Right. So in today's class, we are going to learn about the memory management concepts and graphical user interface and security aspects of the operating system. Let's see what are the different types of memory allocation, the storage allocation. The first one is what contiguous storage allocation. The other one is non-contiguous storage allocation. So in the contiguous storage allocation, there are two parts. One is fixed partition allocation and variable partition allocation. And in non-contiguous, segmentation and paging. So these are the third things which I was talking: paging and segmentation, and fixed partition and variable partition. So generally, the memory will be allocated by the operating system for a program or for a file. So how it will be allocated? Either it will be the entire memory amount of memory will be even divided equally. That is said to be fixed partition. So equal amount of memory blocks will be created and it will be assigned for the particular file or the particular block or for the particular process. Right. And variable partition memory allocation means what? The allocation, it will be done based on the dynamic thing, right? Based on the process, incoming process, or based on the file which is coming, right? So based on that particular file size, the memory will be allocated and it will be given accordingly to the particular process or the file. So this is how the contiguous storage allocation is working. Now, next is our non-contiguous storage allocation, paging and segmentation. So I can say a simple example for the paging, right? See, you can take a textbook reference. So individual pages, right? Individual pages may the content has been defined clearly, right? So that means what the number of lines has been clearly defined for all the pages. So by default, I'm just giving you a rough idea. So 24 to 28 lines it will be given for a particular page. So that much amount of data it will be there for all the pages, right? So slightly just refer this or relate this to the memory. That memory has been divided into equal number of blocks, that is said to be the pages, right? And here there will be a small table, that is page map table, PMT table, will be maintained by the operating system. They're the index numbers of the particular pages, like how the textbook is consist of the index, right? Index chapter number with the page number. Likewise, page mapping table will be maintained by the operating system. So the page number, address, memory address will be defined in that particular table. So whenever a operating system wanted to refer a particular content, so by default it will go to the page number, the page memory allocation table, and directly it will go to the particular memory address. It will refer the content from the particular page. Right. So next one is segmentation. So in the segmentation, the collection of pages together will be separated and it will be said as a particular segment. So it is related to the paging concept, right? So contiguous and non-contiguous memory allocation has been defined with the help of the memory management by the operating system. Next is we'll go in detail about the fixed partition allocation. So as I was talking about the fixed partition allocation, so in this technique, the main storage is split up into the different storage units. That is all said to be what the partition. So P1, P2, P3, these are all what process. So process 1, process 2, and process 3. So equal amount of the memory has been distributed to the processes. So the number and the size of partitions are always, it will be fixed. So there won't be any change in the particular size of the block, right? So the number and the size of the partitions, it can be changed only when there are no programs are executing in that particular partition. So suppose here P1 and P2, so this part has been not used. So this part can be used for some other purposes, right? So when three programs are executing together, if P1 is having the size of 40K and P2 is having the size of 35K and P3 is all about 60K, so then the size it must be, will continue. So when there are three programs are executing together, if P1 is the size of 40K and P2 has the size of 35K and P3 is having the size of 60K, then the size it must be definitely greater than 60K, right? So the number of partitions at least it should be three. And variable partition allocation. So in this technique, the partition sizes are the boundaries, and the boundaries are not at all fixed. So each job is allocated as a partition size according to its requirement. So when a job is finishing, then the particular system is keeping a track of the released storage. So then a partition, it is taking care about the system, like how it has to be organized, right? So the technique, it overcomes the internal fragmentation, though the external fragmentation would persist because it holds the small amount of memory to the job, right? So when the memory is small compared to the job, then there will be a possibility of external fragmentation, and vice versa. If there is amount of memory is bigger than the job, then it is said to be what? Internal fragmentation. So this diagram you need to draw for the variable partitions. So see here the monitor and the jobs. So variable partition allocation, that is 0, it starts from 0K, 0 to 40K, and then 100K, then 200, 230, 256. So 40 to 100K, the job 1 will be there, and 100K to 200K, the job 2 will be there, and 200 to 230K, the job 3 will be there. When if the job 2 is getting terminated, when the job 2 it is getting terminated, that means what? It is getting completed. So if it is completed this particular memory block, it will be free. So if the particular memory block is free, so that the processor or the particular operating system manager will allocate the process or the job or the memory or the file to this particular block, so that the job 4 will get allocated. See, the job 4 size is occupied from 100 to 170K only. So the remaining 30K it is getting free. It is not yet used. Same thing when the job 1 is getting terminated. So this particular block will get free. So this is how you need to explain this variable partition allocation. Then coming to the paging section, as I was explaining you about the paging. So see, partitions, it suffers the external fragmentation because of the memory is not contiguous. Because of the memory is not contiguous. Paging permits a program memory and to be non-contiguous, allocating a program to be allocated physical memory wherever it is available. So wherever the available memory is there, so that particular memory, program memory will be utilized. And physical memory is broken into fixed number of sizes, that is said to be the blocks, and that blocks are said to be what? Page frames. And the logical memory is broken into blocks, and that is said to be what? In same size, that is all said to be what? Pages. So that is what I was explaining you about the textbook reference. So when a program has to be executed, its pages are loaded into the available frames. and then the page map table defined to translate the page user pages to the memory frame. So it will be redirected from that particular memory to the user. So the page size is defined by the hardware, right? That is not at all done by the operating system, but operating system can give an instruction to the hardware. The paging model of the memory, this is the paging model of the memory. So this is the logical memory, and this is said to be the physical memory. Physically how it will be, and logically how it will be, and how the page map table will looks like. See, this is the page frame that I was explaining you, page numbers, right? 0, 1, 2, 3, 4. This is said to be the references. And see here the actual pages are stored. Page 0, 1, 2, 3, right? Likewise, so logical memory, if you see, it will start from the first page, second page, third, and fourth. This is logically which we are thinking, but physically how it will be stored in this way, and how these memories are getting mapped with the help of this PMT. So this is a page number and the page frame number. That means what? Page number is 0123 and 1430 are said to be the frame numbers. That is all about the numbers which will be mapped with the physical and the logical memory. So the PMT plays a role to relate this logical and the physical memory, so that the particular page will be taken out and the content will be given to the user. So how it will work based on this particular PMT. So the address it will given to this PMT, and from here it will go to the physical memory. So these both it will be related with the help of this PMT. So this diagram you need to draw, right? Paging, the content it carries, explanation part it carries 2 marks, and the diagram it carries 2 marks if they are asking for 4 marks. But generally they will ask for 2 marks, right? Along with paging they will ask for segmentation also. So if in that way, diagram 1 mark and the explanation part it is 1 mark. Then coming to the segmentation, right? See here how the entire memory has been segmented. See the main segment of the program, it starts from 0 to 999. See, this is all about the memory addresses, right? Randomly they had taken the memory addresses, right? No need to write the same memory address because it may differ from memory to memory, right? If you wanted to write, then there is no problem. See the segment how they have related, right, in this physical memory, and they have mentioned here. The stack area it starts from 0 to 299, and the sub program it is 0 to 399, and the data area it is all about 0 to 199. So this is all said to be the limits, segment 0, 1, 2, 3, and the other segments. If you want, you can keep it. So this is a segment map table. So how this is related with this physical memory? So you need to see the address, right? So this address, whatever it is mentioned here, that address you need to write it over here. And along with this, the segments are all what the distributions of the particular memory has been equally divided, or you can say variable sizes also, right? The segmentation is, it will be definitely based on the page sizes, right? So the segmentation is said to be the memory management scheme, and it should be the view of the entire physical memory. So this is again, if you see, the paging and segmentation, as I told you, it will be combined together and they may ask for 4 mark question, right? So in that case, this diagram carries 1 mark and the explanation carries 1 mark for the segmentation. Then the next topic is memory map of single user operating system. So single user operating system means in that operating system only one user can use. There won't be multiple users. You cannot create multiple users in that operating system. So the memory map for that single user operating system, it consists of the free memory, process, and then command interpreter, and then kernel. Kernel is said to be the heart of the operating system. So it relates with the process and the memory management. So the command interpreter of the single user operating system is invoked when the computer is started and the operating system load program to be executed in the memory and assigns as much memory as possible. So this instruction set, it is pointing towards the particular memory and it executes the program through the processor. If a program is terminated, then the thing, it will be removed from the memory. So that means it will get terminated, then the entire memory, it will be free. So the kernel of the such operating system, it provides the basic operating system services, while the command interpreter, it gives the commands. So command interpreter and the processor, and along with kernel, along with memory, so the particular operation will be done. Next is coming to the next topic, graphical user interface. So graphical user interface, that you know very well, like how the operating system, command based operating system, has been converted into graphical user interface operating system, right? With the help of mouse icons, and you can use buttons, right? So that particular elements are said to be what used in the operating system to give a command or the instruction to the computer or the hardware device. So this is all said to be what graphical user interface introduction. And the features, yeah, this is much simpler for you, because nowadays we are using graphical user interface only everywhere. So it is very simple to understand and easy to explain also. Then what are the components of graphical user interface? So the components, if you see, desktop icon, and then Windows menu bar, and then individual menus and menu options, each and everything is said to be what, a component of a graphical user interface. This question, they may ask either components of graphical user interface, or you can, they may ask for the controls, what are the controls are present in graphical user interface. So either ways they may ask. And other components like toggle, dialog box, list box, text box, radio buttons, these are all used majorly in the MS Word, Paint, MS Office, complete MS Office, right? And some examples of graphical user interface operating systems are Windows NT, and then server, Open Server Unix operating system, OS2, Novel operating system, and then GUI packages are MS Office, Oracle, Power Objects, Power Builders, right? These are all the examples. Now, coming to the next last concept of operating system, it's very 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 important thing in the theory part, I can say, because from this particular topic there may be two questions asked possibly, because it consists of 5 to 6 questions separately. If you see, 5 to 6 questions are there, so out of that 5 to 6, definitely you may get chances of two questions, getting two questions, right? So what are the different types of questions that we'll see one by one. Now, what is said to be a security aspect for operating system? Security aspect is nothing but to control the memory and to control the data. That is the two major part of the security, right? The memory you have to secure, and as well as the data which is there in the memory that you need to secure. That is the two major parts which is done by the operating system for our computer. The elements of a security, this is again an important 3 mark question. Elements of security, what are the elements of security? One is confidentiality, next is integrity, and then availability. So confidentiality, it ensures the information is not accessed in any unauthorized manner. So means what, unauthorized persons, definitely they will not access any data, or it may not, it may not allow the user, unauthorized user, to enter in also, right? So this is generally related to the read operation. So the content, it will be only available to read, not for write or not for edit. So that is said to be the confidentiality. Then integrity, it ensures the information is not amended or deleted by an unauthorized manner. So the third user, or whichever party user, is not a owner of the particular file, right? If they wanted to edit or delete, right, then that is not at all possible, right? That way it has been integrated, that is said to be right, related to the right operations. Then availability, it ensures that information is available to only the authorized users, so it won't be available for any unauthorized users. These are very very important questions, right, from this particular chapter, operating system. The security aspects, right? So the first question is elements of security: confidentiality, integrity, and availability. Next is security threats. Security threats, there are multiple security threats are there. One is unauthorized use of the service and the unauthorized disclosure of the information, and unauthorized alternation or deletion of information, or unauthorized fabrication of information, or the denial of the services, right? So these are the five different types of security threats are there in your, it may happen in your operating system, right? So how it will be handled by the operating system, or you can explain how, what are these security threats, right? So what is said to be tapping? See here, this diagram you need to diagrammatically you can explain tapping. See here, A is said to be the sender, B is said to be the receiver, and the tapping is said to be the third party user. Third user is also getting the information when the data is transferred from A to B, right? So this is said to be tapping, right? And next is amendment. So A is a sender, B is a receiver. A, that data, instead of sending directly to B, it will go to the third user, third party user, and the third party user, he will amend something else, right? Then the data will send it to B, that is the receiver. So this is said to be amendment. Then fabrication, the data is not sent from A, but still the third user, third party is sending a data which is given by what happened, just a minute. Right, so which is given by the third user by saying that A has sent this information, so this is like fabrication. And then next one is denial. So A is sending a data, trying to send the data to B, but it is just stopping it. What is stopping? Some unauthorized programs, right, is stopping that particular data transfer. That is said to be the denial of the transfer. So these are the five security threats, right? Four security threats diagram is there, but actually there are five, right? And next is computer worms and virus. Computer worms and virus. What is computer worm and virus? Virus is said to be the incomplete program, right? Virus is said to be an incomplete program, and worm is said to be a complete program. So then, what is the difference between these two? If you see, this is an important question. What is the difference between these two? If you see this computer virus, it will not create any problem for the file which is present in the, sorry, computer worms, it will not create any problem for the file which is present in the operating system or your laptop or your computer. But at the same time, computer virus, if you see, definitely it will create problem. What problem? The data it may erase, or the data content it may change, or it may be given to some other person, or it may be content may be deleted, right? So there will be some harms, right, for the particular file which is present in your system. That is by computer virus. But worm, what it will be doing? Computer worm, generally they have designed and developed for the purpose of photocopies, taking photocopies. In the earlier days, they developed this program to take multiple copies, right? Slowly what happened, this become a small program and it started to spread. So what will happen when this worm has been involved into your laptop or computer? The file, it will be repeatedly, it will generate, right? The same file, the multiple copies it will generate. So what will happen? The memory, it will go weak, right? So it will occupy more memory, but it will not create any problem for the file content, but rather the virus, it will create a problem, right? These are the three differences you can write for the computer worms and viruses. And types of viruses, again, an important question. So the questions are related to the security, and virus worms are very, very important. The types of viruses: boot sector infectors, and then memory resident infectors, file specific infectors, and then command processor, and then general purpose. Means in this particular places, the virus can infect. So what it will do? Boot sector. So when the operating system if wanted to boot, so what happened first? The bootstrap loader, the program it will start. That is there in BIOS, the basic input output system. So that particular file it will get corrupted. That is said to be what? Boot sector infectors, right? Then memory resident infectors. Memory resident means what? When the file is there in your memory, right? When the file is there in your memory, that file will get infected. So if that file is getting infected, obviously that memory is also getting infected. Then a file specific infector, only a specific type of file, either Word file, right, or any other type of file, it will get infected. Then command processor infector. So the few viruses place their memory resident code into allocated to command.com. So this is said to be command processor, right? So definitely this, it will crash the entire system, because that is the major thing which we were discussing in the single user operating system. So command processor is said to be giving the instructions to the other things, other places like memory or processor, right? So everywhere this only giving the information or the instructions to the other parts to execute it. If that is a thing is having a virus, then definitely the entire system will get crashed. And the general purpose infectors, it can infect the exe file. So exe executable files in your system, definitely it will get infected, right? So these are the types of viruses which can be done, which can be spoiled your system, right? So this, it can be secured with the help of the operating system. It is not only through the operating system, even through an external program which is executed along with the operating system. Right? Methods by which a virus can infect each other programs, the other programs. One is what? By appending the things to the existing file. So by in this way, it will affect the program, or it will affect the file and replace. In this case, the code, the viral code, it will get replaced with the original content with the another content, or it may be some content will get replaced. So this way the content of the file is getting corrupted. And inserting an external code into the uh, file and delete the entire code, it will be deleted, or the entire file, it will be deleted. Redirect. So the normal flow of the program, it will change from one direction to another direction. Instead of, if you are opening Word document, but if you see it is opening Microsoft Explorer, Windows Explorer, right, or any other thing, so then definitely you can understand there is some virus. So these are the methods the virus will affect the programs, right? So see the differences between these questions. So definitely it may be like little relatively equal, but you need to write it in, explain in a different way. Types of virus, and as well as the methods of the virus which can infect the program. And then mode of operation of computer virus. So what are the mode of operation? What we can do is, what first is virus detection. If the virus is there in your system, right, first you need to understand whether the virus is there in your system or not. If it is there, then first you need to detect it with the help of what? You can detect with the help of what? with a external software, right? So how it will detect the program? It will maintain a checksum. Checksum is said to be the summation of the file size. So the existing file size, how much it has to be there, that particular file size, and the present file size, both it will be compared. So accordingly it will be detected, the virus will be detected with the help of the external software. Then if the virus is found, then it will get removed with the help of the that software only. Then virus prevention, how we can prevent the virus? So the virus is prevented with the help of the external softwares, that is antivirus softwares that you need to purchase officially, legal copies you need to purchase to prevent from the virus. Yes, so that's all about the entire chapter.